Welcome to another Algebra 1 lesson. I'm Mr. Pilarski, and today we're going to be talking about equations with variables on both sides. I work out of the Prentice Hall Algebra 1 textbook, copyright 2009, and this would be lesson 3.3 from that textbook. Our learning objectives for today are: I will be able to solve equations with variables on both sides. I will be able to write equations with variables on both sides for problem situations. Here we have a real-world problem-solving situation. It reads, Acme Copiers charges $250 plus 1 cent per copy, and Best Printers charges $70 plus 3 cents per copy. If n is the number of copies, determine how many copies are needed to make each company charge the same. So we want to know when both of these companies charge the same. So this part of this problem tells us how much, or tells us how Acme Copiers is going to charge. And over here, that I highlight in blue, tells us how much Best Printers is going to charge, or how they are going to charge. What we need to figure out is when Acme is equal to Best. What we need to do then is write an expression that's going to represent the charge for each company. The charge from here, the 250 is a flat charge, so that'll be 250 plus 1 cent per copy, and we need to multiply that by the number of copies. This expression, 250 plus 0.01 times n, represents the charge for Acme Copiers. We want that to be equal to the charge for Best Printers, which charges a $70 flat fee plus 3 cents per copy. So we'll multiply that by the number of copies. This expression represents the number, or the cost for copies at Best Printers. Now we need to solve this equation. To solve this equation, I'm first going to subtract 0.01 n from both sides. 0.01 n and the minus 0.01 n becomes 0 on the left, leaving 250 on the left of the equal sign. And on the right of the equal sign, we have 70 plus 0.03 n. Or I'm sorry, that should be 0.02 n because we subtracted 0.1 n from both sides. Next, we'll subtract 70 from both sides. On the right, the 70s become 0, leaving 0.02 on the right, 0.02 n to be exact, and 250 minus 70 is 180. Next, we'll divide both sides by 0.02. And when we do that, that leaves us with the variable on the right by itself. And 180 divided by 0.02 is 9,000. So what this solution means is that the companies are going to charge the same amount when 9,000 copies are ordered. In example 5T, we're going to be discussing identities and no solutions. We're going to discuss what those mean after we solve each of these equations. In part A of example 5T, we first need to distribute this to negative 2. Negative 2 times 2y is negative 2y. Negative 2 times minus 2 is a plus 4. And we bring down the left-hand side, 4 minus 4y, and put our equal sign in between. Well, this actually should be a minus 4y here. Next step is to eliminate the y, so we add 4y to both sides. And what happens is the y's completely cancel, leaving us with this equation 4 is equal to 4. Now what that means is that 4 is always equal to 4, therefore this equation has all real numbers as a solution, or as we like to call it, the identity. Part B, we need to solve this equation. On the left-hand side, there's nothing to do, so we copy down negative 6z plus 8. On the right-hand side, we combined like terms. Z minus 7z is negative 6z, and we bring down the plus 10. When we go to add 6z to both sides, the 6z's or the z's are eliminated from both sides, and that leaves us with the equation 8 is equal to 10, and that's not true. Therefore, there is no solution. There is no number that's going to make this equation true ever. Back to example A, or part A of example 5t, the identity means that all numbers are a solution. This has been Mr. Pilarski with solving variables on both sides. Thanks for watching. Bye-bye.